Good day, everyone. This is Electrical Distribution 3 for Water Sisulu University students. I am going to be taking you through this course, and this is our first module. Now, the course really is about your generation, transmission, and distribution of electrical energy. And what this first module is going to be talking about is first the history, how electricity started, how generation is being done, as well as how we calculate the costs of generating electricity or the cost of energy, or how we calculate the energy that is produced in our different generation stations. So this first module will be going through all of that. So for the first part of this module, which is today's lesson, we're really going to be talking about the history of electricity in the world and in the country context. And then we're going to be talking about just the different types of generations that we have. So, in our historical development, we pick up that your first time attempt at generating electricity happened around 1831 by a Michael Faraday. Then in 1878, a Thomas Edison developed and sold a gas lighting and heating, and he was doing this utilizing what was generated from that rotary motion using your direct current electricity from it. Then in 1882, that's when we first had our bulb that was able to produce light using your electricity. The first public electricity supply was provided late in 1881 when and it was street lighting in Surrey town, that was in the UK. The system was powered from a water wheel on the riverway, which drove a Siemens alternator that supplied a number of lamps within the town. And it was a year later, in September of 1882, that Edison then opened the Peel Street Power Station. So it was the first power station in 1882, and it was in New York City and was of a DC supply, direct current. The introduction of what we know today as our alternating current was only done in the mid to the late of 1880s, and Europe and the US had the AC power and an advantage in that transformers installed at power stations could be used to raise the voltage, step up the voltage from the generators, and the transformers at local substation, which is the distribution level, could be utilized to reduce the voltage, step it down to our supply load centers. So that was the advantage of the AC system versus the DC system that was utilized before. And your AC power system that is used today is developing on a rapid pace, backed by industrialists and others that contributed to that field. And as I said initially when I introduced this subject, that our electric power industry When we talk about it, we talk about generation of electricity. We talk about transmission of electricity, moving it from your generation power stations to where your load centers are at. We talk about distribution, which is where our load centers are at. So when it gets to that distribution, they are the ones that then gets it to all of the different commercially operating premises and our premises that we live in. And then we also talk about the sale of electric power, where ESCOM typically sells some of that power to the municipalities, and the municipalities sells it to us, or sometimes ESCOM is selling it directly to us as the consumers. The generation of electricity, as was said, that it started around 1882 when we had the electricity that was produced for lighting, and then they utilized those street lights as the next thing that was done. So in 1880 and the 1890s, growing economic and safety concerns led to the regulation of this industry. Now, electricity, we should know by now, it's very dangerous, okay? It can cause you to choke, it can cause you to burn, and it could actually cause your heart to stop. So the electric power was once an expensive novelty, limited to the most densely populated areas. But at this moment in time, it's reliable and economically, electric power has become an essential aspect of normal operation. And that's why we say, or we drive on the fact that says every household should have electricity as a basic need, because it's an essential thing for us to live with. In South Africa, we have what we call ESCOM, which is really the people or the entity that drives electricity in the country. So ESCOM was founded in 1923 in South Africa, and since the 1990s, many regions have opened up the generation and distribution of electricity power to provide a more compatible electricity market. Now, what are those regions that we're talking about since the 1990s? Well, we're talking about first, we had your embedded generation, where people that are producing things like in mines and factories, then they would also have an element that takes some of the waste products that they produce, and they would generate or use those to generate electricity for themselves, and that we call embedded generation. Those started around the 1990s. Then, as the time has developed, we have also had what we call the IPPs, which are independent power producers. Those are your wind turbines, the people that stays in the Transkei or all Transkei, or Amagcuwa, Dutwa, Mthatha. When you live East London and you're driving on the N2 and you get that garage that is written Komcha, and right there, if you're looking on your right hand side, you can see those big windmills that are happening. That is an IPP, and we call it a wind farm. So that is utilized as well to generate electricity. So while such markets can be abusively manipulated, with the consequent adverse price and reliability impact to our consumers, generally, we still need to have a competitive production of electrical energy so that we improve not only the efficiency, but we also improve the stability of our electricity supply in the country. We can stop the load shedding if we have more competitive people coming in and bringing in electricity to us. Transmission and distribution, though, are harder problems since the return on investment on them are not so easy to find as in the generation sphere. So, the importance then of electrical energy is that electrical energy is superior. You hear that? Ne? It's superior to all other forms of energy. And that's why really I chose electrical engineering. And the reason for that is because it's a convenient form. So your electrical energy can easily be converted into any other form of energy. It's easy to control. The electrically operated machines have simple and convenient starting, controlling, and operation mechanisms. It's got a greater flexibility in that it can be easily transported from one place to another with the help of conductors that we have. It's cheap. Okay, so your electrical energy is much cheaper than other forms of energy that you have out there. Your gas is expensive, your fuel is expensive. So, hence, electrical is a cheaper type of energy. Thus, it is overall economical to use this form of energy for your domestic, commercial, and industrial purposes. It's got a cleanliness into it where your energies must not be associated with smoke, fumes, or poisonous gases. But I must admit that at generation there is some form of fumes, but they are regulated and they are monitored, and they need to make sure all the time that they stick within the legal um, levels that they are supposed to be at, so that we maintain the cleanliness that electrical energy is supposed to come with. It's got a high transmission efficiency. Your electrical energy can be transmitted conveniently and efficiently, sorry, from your generation centers. And in most cases in our country, generation is happening in Bumalanga, Lipopo, and then you have the nuclear station that's sitting in Cape Town. So it can be transmitted from those areas uh, into where our consumers are at with the help of your overhead conductors, which we name them your transmission lines. So, our social structures are dependent primarily upon low cost and uninterrupted supply of electrical energy. So, we want energy that is going to be affordable for all, and we want to make sure that interruptions are not there or are as minimal as possible, because it's an inconvenience that it causes. The advancement of a country can then be measured in terms of what we call a per capita consumption of electrical energy. And that per capita consumption really indicates the average consumption by a person belonging to a particular nation, calculated from the known total consumption of that nation and the total population. So it's what I, Tricky is what James, am consuming compared to the total consumption that we as an entire class has or a nation has, and the total population of what that nation has as a country. So your conversion of energy available in different forms in nature into electrical energy, we call that the generation of electrical energy. So generation, all you can really think about or say from now on, instead of saying generation, say it's conversion. Conversion of energy is our generation of electricity. So energy, we know that is available in various forms, okay, from different natural sources, and those can be your pressure head of water, can be a chemical energy of fuels, can be nuclear energy of radioactive substances, and the list can go on. And all these forms of energy can be converted into electrical energy by the use of a suitable arrangements, which is what we are going to discuss further. So the arrangement essentially employs an alternator that will get coupled to a prime mover, okay, and that will what will make the electricity in this case. So I had to have this drawing in here. So you got your energy that is coming from a source, and this source could be your fuel, which can be coal. This source could be your gas. This source could be your nuclear. This source could be water. Okay, and the source comes in here, and this is what we call the prime mover. So the prime mover is where your conversion is happening. And then from the prime mover, we go onto your alternator, which usually represent what we call a generator. And sorry, your prime mover would represent what we call a turbine. And then from the alternator or generator, then you can go out onto your transmission. That's what that RYB stands for. So, in the case of what we call your coal powered stations, we have a steam that is fed into our prime mover or turbine, which may be a steam engine or a steam turbine. And the turbine will convert heat energy of steam into mechanical energy, which is further converted into electrical energy by the alternator. Then similarly, your other forms of energy can be converted into electrical energy by employing suitable machinery that will replace that turbine and that alternator. So for our sources of energy, we can get energy from the sun, and that is where we can have our solar energy. And then for our wind, that's when we have the ones that I described that you go past when you go past Komcha. Then we can have water, and really those are our hydro stations that ESCOM usually utilizes as our peak stations. And then you can have fuels, okay? So your fuels will be like our coal powered stations, which we call our steam generation power stations. Those utilizes coal, which is a fuel sort of a source. And you can have what we have as a nuclear energy with your radioactive energy. And your nuclear, currently we only have the one that is in Cape Town, which is at the ESCOM system. So for the sources of energy, when you look at the sun, you will have heat energy radiated by the sun, and that can be focused over a small area by means of what we call reflectors. And this heat can be used to raise steam, and electrical energy can then be produced with the help of a turbine alternator combination. So Unfortunately, the sun has got limited application because firstly, it requires a large area for generation of even a small amount of electric power. Then it can be used in cloudy days or at night it can't be used. And it is an uneconomical method, therefore. There are some locations in South Africa and in the world where strong solar radiation is received, and you will find that when the IPPs came on board, those areas in South Africa were identified and they have built in their solar farms so that they can be able to generate and feed into the system. But obviously, they have all of these disadvantages. Then we have wind, which is the source of energy. So this method can be used where wind flows for a considerable length of time. The wind energy is used to run the windmill, which drives a small generator. In order to obtain the electrical energy from the windmill continuously, the generator is arranged to charge the batteries. And those batteries supply the energy when the wind has stopped. And this method has advantages that maintenance and generation costs become negligible. However, the drawbacks of this type of energy to generate electricity is the variable output. Today you will have a very windy day. Tomorrow you will have little to no wind. The next day it's moderate. So the output, what you're getting out, is never the same. If each one is designed to be, let's say, 2 kilowatts or 2 kVA, one day you might get close to 2 kVA, another day you might get only one, another day you might only get a half a kVA. And they've got unreliable because of uncertainty about the wind pressure that we have. And therefore the power generated could be quite small. And the next one is water. Now remember, your sun, your wind, your water, those are all natural elements, okay? You don't have to do anything. They just there, God given to us. So when water is stored at a suitable place, it possesses a potential energy because of the head that is created. So this water energy can be converted into mechanical energy with the help of water turbines. And then the water turbines will then be utilized to drive the alternator, which converts the mechanical energy into electrical energy. So this method of generation of electrical energy has become quite popular because it has low production and maintenance costs, and it was employed way before we ventured as a country into wind and solar, and Eskom utilized it as a peak generation so that when our base station, which utilizes your coal and your nuclear, could not handle the supply demand, then these would come in. But with how the country has grown now, those are almost always operational, as you will see in another module. So the sources of energy where we now have fuel, okay, it's now something different. And those are generating stations which convert heat energy of coal combustion. So they burn the coal, and that gets converted into electrical energy, and we call this a steam power station. So the coal in a furnace is like a heater where they throw this coal in, it will heat up water, and the water is in what we call a boiler, which is like a big pot, and then that will convert into heat energy with the help of the steam turbines. So that water will produce some steam, which is what will go into the turbine. So the water boils in the boiler, converts to steam, which then drives the alternator, converting your heat energy of that coal into electrical energy. But if you see, there's actually three different steps. It was your heat, which was heating the water, then the water changed and and became steam, and then that steam, but that was still heat, ne? Is steam. So that steam then was the one that drives the alternator and converting to electrical. So this method of generation of electrical energy is what is most popular in South Africa. We've got a lot of steam power stations. As I said, we have a couple that's in Mpumalanga. We have one or two that's in Limpopo, and I think we have about one that might be in Gauteng, if I'm not mistaken. And then your nuclear, it was discovered that large amounts of heat is liberated by the fission of uranium. And this is used as a fuel in nuclear reactors. And other fissionable materials, which are called nuclide, is material that is capable of undergoing fission reaction after absorbing either your thermal, which is a slow or low energy neutron, or fast high energy neutron. So it is estimated that the heat that can be produced by just 1 kg of the nuclear fuel is equivalent to that can be produced by 4,500 tons of coal. So just imagine the difference. 1 kg compared to 4,500 tons. So the heat produced due to the nuclear fission can be utilized to raise steam with suitable arrangements, and that steam can run your steam turbine, and it can then turn and drive an alternator and produce your electrical energies. There are some difficulties in the use of nuclear. We know most nuclear is dangerous, but besides that, it's high cost for nuclear plants, and there is the problem of disposal of those radioactive waste and death of trained personnel to handle the plant because of the high danger or the toxic the toxic nature that nuclear is at. And this is the last slide of our lesson, and we're going to have three more lessons on module 1 to complete the generation. And really what this slide is doing is comparing your generation between your water power, your fuel powered, and your nuclear powered stations, and is comparing them against your initial costs, your running costs, your reserves that you need, how clean that generation is, simplicity or complexity of it, and how reliable they actually are. Thank you. Please do study this and know how to compare between the three.